Good evening to all. Welcome to the screening of Sir Fred Hoyle, the man ahead of time. We gather here for the screening of the documentary based on the life of Sir Fred Hoyle. I would request Dr. Arna Mukherjee, faculty in charge of the Media Center, to welcome the gathering.
Okay, I welcome you all on these occasions of screening of Sir Fred Hoyle's life and work, a documentary made by Science Media Center and some students. So basically, before I talk about the documentary itself or the origin of this documentary, I would just like to mention about Science Media Center to those who are not aware of that. So this is a place instituted by IISER Pune where people try to make an effort to communicate science in simple terms. So one of the activities of Science Media Center is to make scientific videos in such a lucid manner, in a popular way, such that it can reach to many people. Also, they host workshops for scientific communication writing and other online based portals like NPTEL or MOOC or SWAM where there you can find lectures. So those lecture videos are recorded and edited by our Science Media Center people. Now there are more than 10 people there and they're extremely talented. They have the skills of animations, editing and many other things. So apart from IISER Pune's activity, we also help out, wherever any help required from other places like IUCAA and NCL, in Venture Center, and many other projects are going on. So now coming back to the or inceptions or origin of this particular documentary is that it was an initiative by our own IISER Pune student. I think 2013 batch student. So in the year 2015, in the 100 years of Professor Sir Fred Hoyle's life, so some students thought to make a documentary, and that year actually there was Indian Planetary Society organized again its conference on Einstein's general theory of relativity, and also to celebrate or commemorate 100 years of Sir Fred Hoyle. So those students actually talked to Professor Narlikar, and who was of course the student of Sir Fred Hoyle, and with his help they could get some interviews from people, some scientists there who also worked with Sir Fred Hoyle. But somehow the documentary could not be finished because the student had to leave in 2017. Now, and Science Media Center in the meantime grew larger, and with more force and more enthusiasm, they took the initiative. So in the first part, I just came recently. I just took charge of. It's not basically a charge. There should be a faculty assigned to this. Main activities are done by people in Science Media Center, especially the people there, like Vivek, who is a senior technical officer, and along with others. So recently, Suchi brother joined, and she took also the initiative to finish this, and then they did a lot more work, and finally could bring it to a point where we can now screen it in front of you. So with that, again, I welcome you all, and hope you will have nice time there. Thank you.
Thank you, Dr. Arnab. We have Professor Tarun Souradeep with us, Professor and Chair, Department of Physics, IISER Pune. He doesn't need an introduction. A renowned astrophysicist himself will talk on Sir Fred Hoyle's work. Please.
So I must say, it's an immeasurably great privilege to get this opportunity to introduce Fred Hoyle. I never imagined that I'll get such an opportunity, but here it is. And so I'm very glad that Professor Narlikar will be speaking right after me. So, I think he will be able to correct things which I may not have thought through. But, let me try to give a flavor of what I felt about Fred Hoyle. I had the, I was lucky enough that in the early 90s he did visit IUCAA, and I had the privilege to meet him then. So if I were to summarize this whole thing, so I actually gave a slightly different subtitle, which is to say every time he seemed to be a person who seemed to be thinking where no one else seemed to be focusing on. So somewhat like the Star Trek motto of going where no one else has gone before. And that led to him to pioneer great ideas. Some were considered radical, some controversial, but that's not important. But what is important is all his ideas are amazingly beautiful, and if you hear him talk about it, it's very convincing. So one of the things I had the privilege of hearing was when he came to IUCAA and talked about panspermia. I was a early graduate student, and I remain quite convinced that of his arguments still now, and I'm hoping that someone in the biology department could sort of illuminate why that is not quite the case. And similarly, there was this entire area where of fundamental physics, where there's a new theory of gravitation, which Professor Hoyle and Professor Narlikar championed, which was essentially a modification of general relativity to take into account or to be consistent with some beautiful principle called the Mach's principle. And I won't have time to go over it, but go into it. But it also had interesting ideas like action at a distance field theory, something although that's not very popular now, was even pursued by people like Feynman, and I think people would realize that that must have been a very important thought at that point. And there are many other offshoots of which some I also had a little opportunity to dabble in the early years. So his biggest, idea, which is was radical when it was proposed, but also happened to stick and is the current paradigm, is cooking atoms in dying stars. And you will hear some of the details in the talk, as well as I'm sure Professor Narlikar would talk about it. And this was the first paper in 1946, and which is when he first proposed that stellar nucleosynthesis would be kind of possible in dying stars. So when stars finish their life, densities would and temperatures would be large enough that statistical equilibrium would cause them to form almost all the nuclei that you see in the periodic table. And that he pursued relentlessly for a decade and culminated in a very famous paper. It's called B2FH, which sort of explains all the elemental abundances. And that is actually the modern paradigm of stellar nucleosynthesis. So then there is this whole question which many of us have heard about, and most people would be, hearing about whenever you talk about Fred Hoyle, is his view on cosmology. So we have a cosmic stage we need to understand. Now, obviously, there are different interpretations, and he did believe in an interpretation. So this is a quote from him, that hot Big Bang may not be the true model. And again, what I should emphasize is whether a theory remains or not. The thought process is very important. There are very deep thoughts into it, and what is the unsatisfactory nature of it, some of it still holds. And as he said towards the end, I guess, it's again a quote from him which says, the establishment defends itself by complicating everything to the point of incomprehensibility. Being a person on the other side, I do agree to some extent that that is possible. We actually are sort of relying on keeping an idea alive through many things that we do not understand very well. So one of the main things which sort of touches upon my thing is the microwave background radiation, and so I'll read it out. So what I wanted to show you is the Planckian radiation, which was serendipitously discovered and is heralded as the kind of clinching evidence for hot Big Bang. And of course, there is an alternative, and that comes in the quasi-steady state, which was proposed. And what I wanted to show here is a cutout from a nature paper that Fred Hoyle, Narlikar, Professor Arp, they all wrote, which I distinctly remember, and I can quote verbatim. They said, there was a paragraph, it said, when a person wakes up in the mountain and is surrounded by fog, he knows that he is in a fog. He doesn't think he's seeing the beginning of the universe. And that was the nice way of differentiating between whether the microwave background radiation is cosmic, which is the so-called the standard paradigm under which most cosmologists are working, or is a local effect. And that is, again, interesting. So I think you can read a bit of it, the common sense inference. So all the time I noticed that the things where he says common sense, he really relied a lot on the strength of common sense. For example, one of his quotes says, the best way to remove an electron from an atom is to rub two surfaces. People always, if you tell someone how to do it, you'll think of, very high, tech instruments to do that. So I should just end with saying that I also had the privilege to be a co-author on his, I guess it's his last research paper, where we actually tried to see how quasi steady-state cosmology could match up to the measurements that were coming from the CMB background. And this was in 2003, and I think by the time the paper came in print, Professor Hoyle had passed away. And so I think that is really a big highlight of my thing. So I won't stand between you and Professor Narlikar, who actually knows him very closely and would be talking about Fred Hoyle. Just to show you that, there are sites which I encourage young students to go and see, and it's worth exploring the life of such a great intellect. Okay, and it's important to realize that science is done in various ways, not one. And as he himself has quoted there, and some of the journeys are necessarily ones where you are not comfortable, you are not so-called on a bandwagon, as Jayant often has mentioned to us. And I hope students will take some lessons from this film as well as the talk that Jayant gives. Thank you.
Thank you, Professor Tarun Souradeep. I would request Professor Prasad Balasubramaniam to give a memento to him. Thank you, Professor Prasad and Professor Tarun. I would request Professor Jayant Narlikar, the founding director of IUCAA, to the stage. Professor Narlikar was not only a doctoral student of Sir Fred Hoyle, he was also his collaborator and companion till his last days. I request Professor Narlikar to tell a few words about Professor Sir Hoyle.
First of all, I want to congratulate the organization which has made this film. I happen to have an early view of it and I liked it, and the initiative taken in making the film is what I admire. I want to say a few things about Fred Hoyle, who was my guru, as you know, and what I want to emphasize is some of the episodes he described in his autobiography, which was, in a sense, telling us about his early days. So one of the incidents, and what I'm going to tell you reflects on telling us what he was going to be like when he grew up. So you are looking at Fred Hoyle when he was small. So the first experience I want to describe was when he was apparently 3 years old. Normally you don't remember anything what you did or you didn't at 3 years old age. But Fred, of course, had certain ideas and he remembered and he describes them. And what that was they had a grandfather clock in the house, it was a stand-up thing with big thing and had hour hand, minute hand, so on. And Fred had been fascinated by that contraption because it was a working clock. So the minute hand and hour hand were moving. So he saw this and he started asking the elders in the house what time it was. He did not want to know how the system works, but he wanted to know. They keep saying it is 5 o'clock, it is 7 o'clock. So it's something to do with time. So he said, please, what is the time? He would ask. And any time of the day. And whoever happened to be around would look at the clock and say it is 7 minutes past 8 or something. And he noted that these figures, how many minutes past what hours, happen to be correlated with where these hands are. So, saying it is so many hours past something, that was an indication to him of how this machine works. And this is how he finally worked out and he could tell the time whenever asked for. Now, the moral from this is that when he grew up and he came across something new, he did not want to be told what it was. He wanted to work it out himself and use all the logic and facts that were needed to understand whatever system it was. So this was the first thing I wanted to tell about Fred. The second was at a later age, around 8 or 9 years old, when he was in primary school, and the teacher, class teacher, had asked all the children in the class to go and collect samples of a certain type of flower. And she said that this flower has 5 petals that you will find. So they all went around and brought samples of that particular flower, and all of them, except one, had 5 petals. But the one exception happened to be Fred's. The one he collected had 6 petals. So his question when he came into the class was to ask the teacher, Madam, you said that the typical flower has 5 petals, but mine has 6. How is it? If it were four petals, he could have understood or explained this by saying that there were 5 originally and one fell down. But with this kind of 6 petals, you cannot explain from any normal information available. So the teacher got annoyed because she thought that this young boy is trying to prove her wrong. Since she said 5 and it is 6, she must be wrong. Although he didn't mean it that way, he was asking, but even being asked was not liked by the teacher. So she twisted his ear just by way of punishment. Now, subsequently, he tells me, I used to tell others also, that he became partially deaf And that must have been because of that twisting of the ear. But that was separate. The fact that the teacher didn't reply to his question and instead punished him for no reason, he got upset. And he took his whatever books or things were and left the class and walked home. So his mother was at home. She said, "What is it? Why have you come back like this? And was the school closed or something?" She said, "No, no, I walked out because the teacher is not following any logical rules. Whatever language he used was simpler than this, but he said that the teacher was uh, not giving the right answer, and he gave all the account of what had happened and so forth. And he had brought that flower with him when he walked as evidence, because in case there is an inquiry, then this should be around. So he came, he explained to mother, and the mother said, "Okay, tomorrow we will go and meet the principal or headmaster, as they call it." So next day they went to see the headmaster, explained to him everything. The boy explained, the mother corroborated, saying that this is what he told yesterday, and that seems. They asked the teacher to look in and say that, so that the teacher was not very cooperative, and she felt that she was being harassed. And so she refused to apologize. And Fred said that unless she apologizes, he won't go to the school. Now, the rule in Britain was, and it still is today, that everybody of a given age must be in the school. He can't be at home. So, the headmaster said, "You have to go to school." He said, "Yes, I will go to some other school, but not this one, because here the teacher is not uh, behaving in a logical way." So they discussed all these implications, and the thing was that they wanted to respect Fred's experience and say that what he said was the situation. So he should not be punished. At the same time, he must attend the disciplinary rule that he must go to school. So the teacher, the head teacher, headmaster said, uh, now the term is coming to an end in a couple of weeks or whatever. So I can give him permission to work at home if the mother is going to take responsibilities, which she did. And then next term, when it begins, we will admit him to another school. And that is how he was admitted to the next school after some 2 or 3 weeks of studying at home. Now, this example from his early life shows that he was expecting logical behavior, and it has to be uh, obeyed. Otherwise, there is no point in any interaction. So that feeling that Fred had from the early days was worth noting. Then there was, I will tell you one more story, and then I will uh, back off and listen to others. The the bigger school that he was sent to after the term was over was not very close by. So, and in fact, he had to go for a couple of kilometers or miles, walking to go to the school. he used to do this kind of long walks even then because father and son both used to go on certain good observing nights to see a friend who had a telescope, 4-inch telescope, which was on the rooftop. So they used to walk several kilometers, miles, to reach that and do the observing and come back in the early morning. So he was fond of walking and he had no problem. But his mother found that there was a rule of municipality that if the distance from the place where the child is to where the class is, if the distance, walking distance is more than a certain critical value which was given, let us say 2 miles. If it was more than 2 miles, then the, the rule said that the child was entitled to bus fare. He could be reimbursed for his bus fare. He could take a bus. So this Fred went and tested how long it was. It was more than 4 miles, 2 miles. So he said that this I should qualify for this. So the municipality, since it was a financial matter of paying the fare or something, the accountants are the same everywhere. They want to see how to save money for the institution. So the accountant said, I will go and look at the terrain and say how far it is. So he went and did some testing. And then he came saying that the boy says is correct, it is more than 2 miles. But there is a shortcut across the farm. There is a farm in the way. And if he climbs the gate and goes and then climbs out again, he is less by just a few minutes. And so he need not be paid any fare. So this was measured and told, so Fred did not object. But this example shows what kind of the mentality people have. And anyway, so finally, I will jump to the end of my talk and say that when I was making a PowerPoint presentation of on Fred Hoyle, there was one photograph which John Faulkner, who was a fellow student of mine, fellow student of Fred Hoyle, but we were both students of him, and he said that there is in St. John's College, which is the college of Fred Hoyle, there are all these papers of Fred, and in that he saw a photograph, and that photograph I might like to have a copy of. So I said, what photograph it is? So he said it's a photograph taken at the time of the IAU meeting in 1950. And at that time, it was held in Rome, and the result was the local host was the Pope. And the Pope, in his opening address, blessed the Big Bang cosmology as the right cosmology. And so there were some people who were at that time opposing, including Fred and John Claude Pecker and some others, that they did not want to support Big Bang. So it was known that there are some of these people who are against Big Bang in this, or against what Pope had blessed. So at the time of get-together, when the Pope was present, some important personalities were brought to be presented to the Pope for their courtesy kind of thing, that they are coming from far away and we are the hosts, so Pope wanted to be polite. So this photograph was taken when Fred Hoyle was introduced to the Pope. And that photograph shows, if people are interested, I will put it on the website or something. But what the photograph shows was that Fred is shaking hands with the Pope. And at the same time, the Pope he had his right hand for shaking hand. The left hand he was holding the cross, which was hanging from his neck. It looks as if seeing this gentleman who is against Pope, against religion, he has to protect himself from his magic. So he was holding the cross. That is what everybody thought. The photograph was taken by Willie Fowler, who was immensely amused by this interpretation. I think I will stop here. Thank you.
I would invite Professor Sunil Mukhi to give over a small memento. And by the way, it's also a 5-petal flower.
Okay. Thank you so much. Thank you.
There would be a video message from Hoyle's family, which Professor Sunil Mukhi has received. He would screen the video message just before the screening of the video.
Okay, so I'm not really part of this program, but I've sort of butted in for 5 minutes, and I'll use those 5 minutes for 3 things. First, I'd really like to thank Jayant Narlikar and Mangala Narlikar for being here, as well as all other distinguished friends from IUCAA. But it's particularly an honor. It's like always been an honor to hear Professor Narlikar. And I'm glad he told this story about logic and rationality, because at least for me, in my career, he has been a beacon of logic and rationality. He has written about it in English, in Marathi. He has written in newspapers, magazines. And I think in addition to his immense science contribution, I think I personally would like to take this opportunity to thank Jayant for propagating the scientific viewpoint in the public sphere in our country. So, and I think it's been a great pleasure hearing his personal memories of Fred Hoyle. Now, that's one thing. The second thing is that by chance I happened to know Professor Fred Hoyle's daughter, Elizabeth Butler, as well as his granddaughter, Professor Samantha Butler. And I told both of them a few days ago that IISER has made a movie about Fred Hoyle, and both wanted to send a message congratulating IISER and thanking the students and the media center. So first I'll read out Elizabeth Butler's message, which is a brief one. So, hello, I am Elizabeth Butler, Fred Hoyle's daughter. I would very much like to add my thanks to everyone involved in the organization of today's event, and also to wish you all a thought-provoking evening. My father was passionate about science for every day of his life, from the tender age of 10 to about a month before he died. Actually, now we know from Jayant that he was passionate about science from the age of 3, possibly, when he started studying clocks. Okay. One of the rare things about him, this is from the note, was that he believed the whole sweep of science needs every available pair of young eyes and all youthful thought to help propel human knowledge still further out into space. He believed that youth was absolutely vital to the health of all scientific research, and his belief went against accepted practices of his day. He also believed that these young eyes and thoughts must come from any place at any time and from any background. Hopefully, as soon as next year, some of my father's serious science work will be back in print, and a whole new generation of students can read for themselves such works as Nature of the Universe and Frontiers of Astronomy. Best wishes, Dr. Liz Butler. So that's the message from Professor Hoyle's daughter. The message from his granddaughter, who is a professor of biology at UCLA in Los Angeles, California, is here, and I'm about to play it for you. It's just a 2-minute video, and right after that, without any break, we'll go into the actual movie for which we have all come here. So I hope the sound is okay.
Hello from Los Angeles, California. My name's Samantha Butler. I'm a professor at UCLA. I'm the Eleanor Leslie Chair in Pioneering Brain Science. But I'm talking to you today because I'm both a very old friend of Sunil Mukherjee's and the eldest granddaughter of Fred Hoyle. And I'm talking to you, to the students at IISER, on behalf of the Hoyle and Butler families to thank you for making this documentary about Fred Hoyle. So I first came to India as an 18-year-old girl when I visited TFR in Mumbai for 6 months. Many wonderful things happened to me on that trip, of which the most notable were first getting to know Jayant and Narlikar, who looked after me during this period. One of the most memorable times was when my grandparents came to visit. We saw many wonderful things on a trip across India, but the most happy moment that I remember was sitting around the Narlikar's table at in the Bhaskara colony eating a wonderful dinner. It really was a very happy time. The second thing that happened was that I got to know the generation of trainees at TFR at that time, both in astrophysics and in theoretical physics, and this is where I met Sunil. And that was a wonderful group of students. It included many people who are now luminaries of science, Indian science across the world, and it propelled me into my own career of science. Their passion and joy for science was infectious. So again, I want to thank the IISER graduate students who made this documentary about my grandfather. I am tremendously looking forward to watching it. Would my grandfather have enjoyed it? That's hard to say. Who wouldn't, on one hand, who wouldn't enjoy having a documentary made about them? But on the other hand, I wanted to share just a little fact about my grandfather, which often doesn't come through in his biographies and the articles about him, which is that he was not self-important at all. He didn't like talking about himself. And I didn't think much of this as a grandchild, but I have to say as a scientist, I've come to recognize that's unusual among the great men of science. So, but he did passionately care about, of course, about his science. And the fact that students still, 100 years after his birth, are still actively discussing it and making documentaries like this one would have meant the world to him, and it means the world to his family. So again, I thank you on behalf of the Butler and Hoyle families.
In 1983, Professor William A. Fowler and Professor Subramanian Chandrasekhar received the Nobel Prize in Physics, the most prestigious award of all time in science. That year, the theme of the Nobel Prize in Physics was stellar evolution. It came as a surprise to the scientific community that Sir Fred Hoyle, a pioneer in this field, was excluded from the list of Nobel Prize, for this was an area in which Fred Hoyle had richly contributed.
Fred Hoyle was an iconoclast. He did not necessarily believe something which was believed by everybody.
He was a man absolutely dedicated to trying to understand the universe.
I think he's an absolutely remarkable man. It's probably fair to say that he changed the way we see the world.
His contribution to nucleosynthesis formed one of the very important bases of overall structure of modern astronomy, as it were.
Being my father's daughter was a bit like being the daughter of a pop star. You have no idea the excitement my father could generate.
Sir Fred Hoyle was one of the most creative and outspoken astrophysicists of all time. He is remembered for his contribution to the theory of stellar nucleosynthesis. and his often controversial stance on cosmology, such as steady state theory, panspermia, molecular clouds, etc. Despite his numerous contributions to cosmology, Sir Fred Hoyle was one of the unfortunate scientists who did not receive the highest award in science, the Nobel Prize.
Let's call it the bandwagon bus in which everybody who believes in the popular theory rides. Now, you can be of three kinds. You can be late in boarding the bus, so you miss the bus. The second is you get on the bus at the right time, so that for your career you are making the right kind of contributions and you succeed. If you are too much in advance of the bus will come and knock you out. Now, in the case of Fred Hoyle, this was the last alternative. He made many statements and contributions, but they were before their time, and after the bandwagon came there, they had forgotten that he had said this.
Fred proposed that the energy-producing reactions in stars, known as nucleosynthesis, was the origin of all chemical elements.
I worked on nucleosynthesis. I would say, as a result of my work, he and I realized one had to look for other ways of producing the particular kinds of nuclei that he was interested in.
The way in which energy is released during the process of nucleosynthesis in the interior of stars is pivotal to our understanding of the manner in which stars evolve, stellar evolution as it's called. And this is arguably one of the pillars of modern astronomy.
He was contributing to formation of elements, that is chemical elements, how were they formed. So there was a famous paper by Burbage, Fowler and Hoyle, which tells you how these elements were synthesized in stars. And this is called B²FH as the short form for the four authors.
The B²FH paper is considered a landmark in the origin of the chemical elements. The four authors were Margaret Burbage, Geoffrey Burbage, William A. Fowler, and Fred Hoyle. As Fowler said in his autobiographical sketch, the concept of nucleosynthesis in stars was first established by Hoyle in 1946.
He was almost the first, possibly the first, to recognize what is nowadays taken for granted, that almost all the material that this planet is made of was formed inside stars. Before the sun formed, before the planet formed, there was still 10 billion years of stellar evolution, and these stars turned hydrogen and helium into carbon and oxygen and neon and iron and zirconium and barium and lead.
Sir Fred Hoyle was often involved in controversy due to his honest opinions. He established the Institute of Theoretical Astronomy in 1967, which was later renamed as Institute of Astronomy, Cambridge. Though his leadership led this institution to become one of the premier institutions in the world, he left his position as a professor in 1972 and the directorship in 1973.
I was a PhD student in Cambridge and a postdoctoral fellow there. He had left Cambridge after a disagreement with Cambridge in the 70s, but towards the end of the 80s, Fred Hoyle started coming back to Cambridge for periods of a time. His collaborators, Professor Narlikar and Professor Vikram Singhe, the Burbages, they all started coming to Cambridge when Fred Hoyle was there.
One of his reasons for his arguments with the scientific establishment in Britain was because he felt that this system of checks and balances, grant systems, referee systems, effectively favoured the big beasts like himself, and it made it very easy for young, enthusiastic minds to be shut out.
He set up the Institute of Astronomy, and after he had left, the Hoyle building was named after him. There's a life-size statue of Fred Hoyle in the gardens outside that building. They celebrated Professor Fred Hoyle's 75th birthday. I remember that this 75th birthday celebration was held, pictures being taken with Professor Fred Hoyle standing next to his statue and everybody around. I wish we had camera phones then. I don't have records of these pictures. Almost everybody would have now taken selfies with those illustrious people around.
American astronomer Edwin Hubble proposed the Big Bang theory in 1929, a theory of the origin of the universe most widely accepted today. However, to Fred Hoyle, the Big Bang theory seemed to be far from perfect. There had to be an alternative cosmology.
Why do we need an alternative cosmology? So the Big Bang requires you to make an assumption that there is a lot of non-baryonic dark matter present in the universe, and that in itself I feel is an artificial assumption put in to prop up the theory, otherwise the theory breaks down. Steady state theory was one of the brilliant ideas proposed by three scientists, that was Hermann Bondi, Tommy Gold and Fred Hoyle. And they had proposed that the universe is without beginning, without an end, and it continues to expand at a steady rate. But if something expands, its density falls. So to keep it in steady state, you need to produce more matter in place of the old one. So you have to continuously provide matter.
The steady state theory immediately aroused bitter opposition.
So this idea was rather new to physicists, who thought that the conservation of matter and energy is being violated. But what Fred Hoyle showed with his mathematical work, that if you had negative energy fields, then creation of matter does not violate principle of energy.
Numerous attempts were made to reject the theory with observational arguments. Martin Ryle was one of the most powerful and controversial critic of this theory.
Well, Martin Ryle was a radio astronomer who conducted counts of radio galaxies out to different distances, and he found that the number of radio galaxies per unit volume went on increasing very rapidly as you went further and further, and he came to the conclusion that this kind of behavior is not explained by the steady state theory. So he said that his data was disproving the steady state cosmology.
I think initially his feelings of argument, if I can book it with Professor Ryle, was because Professor Ryle was a deeply religious man, and you know, let's be honest, between us all standing in this camera, you know, God created the world in 7 days or whatever it says, you know, Big Bang. And I think that was his initial stepping backwards. I think when the evidence continued to come, he obviously agreed with it.
By the 1960s, the steady state theory had been completely rejected after the detection of cosmic microwave background radiation. But Fred still felt that a different approach to cosmology was indeed needed. Together with Jayant Narlikar and Geoffrey Burbidge, in the final years of his life, Fred worked out a quasi steady state theory of the universe. The result of the collaboration between Hoyle, Narlikar and Burbidge appeared in the form of a book titled A Different Approach to Cosmology.
Well, the quasi steady state theory would like to have certain observations done so that it can be tested. Now, one of them is that it predicts that there can be or should be very old stars present, something like 20 giga-year-old stars. If that is found, then it will be difficult to explain in Big Bang, but the quasi-steady state can do it.
People believe he clung to the steady state theory with sort of like some sort of old Harrigan. This was not my father. I actually asked him this question. It's very rare for me to do so, and we were having English high tea, which is scones and jam and tea and things by the sea. We were just the two of us near where they went to live. And I said, what do you think about Big Bang? And he took a large bite of scone and jam and cream, and he said, well, I don't like it because it leaves more questions than it answers. But he said, The evidence points towards it, and then took another bite of his scone and finally he had a very good, nice grin, and then gave me a big grin. He said, "I'm difficult, but I'm not irrational."
In 1960, Fred was joined by Chandra Wickramasinghe, a research student from Sri Lanka. They together proposed that life on Earth had an extraterrestrial origin, an idea popularly known as panspermia.
I think it's true to say, isn't it, that if your theory is correct, life not only may be spread throughout the universe, it must be.
Surely there must be many places where this has happened. Do you have an idea of the numbers?
The numbers must be very favourable, Fred. There are billions of stars in the galaxy which are probably very similar to the Sun, and very similar to the extent of being able to support planetary systems. So it would really be very surprising if life is not, if the galaxy is not just teeming with life.
However, the scientific establishment was not ready for such a provocative idea at that time.
I'd learned from Fred Hoyle that you don't really take note of other people's criticisms. You have to really take note only of your own self-criticism. He instilled in me a kind of obstinacy, meaning that you should not be deflected from your intended path unless you really have very powerful reasons to shift away from it.
I've seen Professor Hoyle give the very famous lecture at the University of Oxford on his theory of how life came from outer space through comets. And again, this lecture, the Halley lecture, in the 80s, I remember there were 300 to 400 people in the room. Nobody believed a word of what he said. But you came out completely convinced that there was a case for it.
Fred Hoyle later collaborated with his student Jayant Narlikar to perform few high-altitude experiments to detect organic materials with possible origins in outer space. During these experiments, a few new species of bacteria were found high above the ground in the stratosphere. One of these species was named Janibacter hoyle in the name of Sir Fred Hoyle.
These experiments are called as astrobiology balloon experiments, and those were conducted twice, once in 2001 and next time in 2005. Primarily, these experiments were started to test the Hoyle-Wickramasinghe hypothesis of panspermia. So, 2001 IUCAA, TIFR and CCMB in Hyderabad, they did these experiments. Those experiments were successful. They could indeed find some live bacteria over there, and in fact some new species of bacteria. Since this experiment was done to prove the Hoyle-Wickramasinghe theory of panspermia, this organism, which was found in the air sample that was collected at 41 kilometers, we named it as Janibacter hoyle. It's very creditable that a person who do not have any formal background in biology or microbiology come up with this theory of panspermia. That's a very genius of him to think of such an explanation.
Fred Hoyle was a great science communicator. He knew that science is not only for the scientific community. Laymen can equally be interested in the wonder of science if it is delivered in a simpler way.
His real interest was in projecting science to people who were non-scientists. People have come up to me and said, I never thought of science as being interested until I heard your father talk on the radio.
I would say there are very few scientists who take science popularization as a serious part of their work. But Fred Hoyle was one of them, and he was very good both in his speeches on scientific subjects, but also in his writings, as well as television interviews and so on.
Fred Hoyle was awarded the 1967 UNESCO Kalinga Prize for the popularization of science through his television programs and lectures addressed to the general public. He had written many fiction and non-fiction books, among which The Black Cloud is the most popular one.
In which he had made the conjecture that inside the galaxy there are regions which produce somehow chemical elements, not chemical compounds. So he said that we should look for such regions inside the galaxy, and they could be called molecular clouds because molecules were found. That idea was part of the whole story, and the science fiction story was very popular, and the idea got known.
Well, he was a wonderful communicator of science. I knew about him from a radio broadcast or series of broadcasts he had given some years earlier when I was still a schoolboy, but they were absolutely fascinating. You know, Fred's one interest in life was to try and understand things. And if you wanted to try and understand things, you were his guy.
Sir Fred Hoyle was born to Mabel and Ben Hoyle on the 24th of June 1915 in the village of Gilstead near Bingley, Yorkshire. He married Barbara Clark on the 28th of December 1939. They had a son Geoffrey and a daughter Elizabeth. He had a strong personality since his childhood. He skipped school very often. For him, the outside of school was more interesting than the inside. At the age of 8, one day, he had an argument with his teacher about a flower petal. The teacher said that the particular flower contains precisely 5 petals. However, Fred found a flower of that kind with 6 petals. He told the teacher that the flower need not necessarily follow the rule of 5 petals. The teacher slapped him for having a different opinion. So he decided not to visit the school after that. Fred was homeschooled by his mother for the rest of that period. This incident shows the curious and courageous mind of Fred since his childhood. He was born to fight for what he believed in.
I think he was always a man in a hurry in some senses. He saw so many questions that needed answering in his mind, and with the limited availability that you had before the internet, he looked for data, and when he found an answer that might fit, he would then talk to people and see whether it fitted. That meant that he got things often horrendously wrong, but when he did get them right, he got them extraordinarily right, in a way that is almost unbelievable. How can you believe it at not much older than you? He walked into Willie Fowler's office in Caltech and said, this part of a carbon atom exists because I exist.
We are open for discussions. I would request if you have questions, you can ask Professor Tarun Souradeep. We have Professor Ajit Kembavi as well as Professor Dadich here. If you have questions.
Hello. My question is to Professor Jayant Narlikar. In his book, in his autobiography, Char Nagaratle माझे Vishwa, he also mentioned that he also worked with Dr. Richard Feynman. So I want to know that how was his experience working with Dr. Feynman?
Hello. I had a few discussion sessions with Feynman, in which, since he had started the whole subject of action at a distance, it was natural for us, that is Fred and me, to go and consult him on some occasions. So we found him very cooperative and was very good in making suggestions, which we found useful to follow up. So the ultimate, his ultimate decision was that he had tried to push action at a distance all the way to quantum physics. He could not quantize action at a distance, so he left it there. So he was quite appreciative when we showed him our work in which we had quantized action at a distance. And he said that this kind of approach can be continued in future.
My question is to Professor Tarun. So the steady state theory requires spontaneous creation of matter. So wouldn't that mean that on average, if you look at the sky, wouldn't the entire sky be as bright as, say, the surface of stars? Because over the time, so much matter would be spontaneously created that gravitationally they would be attracted and form stars. So much more so because the universe would have existed forever. So wherever we look, wouldn't the sky be too bright than what we observe right now?
So what you're pointing out is very well known as the Olbers Paradox. So even if you worry about the static universe where you look at the surface of galaxies, as they go further away, they subtend a smaller angular diameter, but their numbers increase at the same rate. It's r square, and so you should actually see a sky which is as bright as the surface of stars, and that we don't. And the part of the reason of that is the expansion of the universe and the red shifting of light. And those aspects are there in steady state theory. So I don't think there's any problem of that kind specific to steady state theory versus Big Bang in that context.
I'll just read out the vote of thanks. First of all, thank you all, almost full auditorium, to everyone to be part of the event. I start with Professor Jayant Narlikar and Dr. Mangalam Narlikar. I thank you for your devoted involvement, because from the beginning of the project, you have been our inspiration to do this project. And without your help, this would not have been possible. Professor Tarun Souradeep, being our guest speaker, chief guest of the event, with his busy schedule and all. Thank you so much, Professor. My heartfelt gratitude to Professor Peter Eagleton, Professor Chandra Vikramasinghe, Professor Somek Raj Chowdhury, Professor Yogesh Shauche, and Professor Prasad Balasubramaniam for being part of the video. We are grateful to the family of Sir Fred Hoyle. They have been supportive since the beginning, and thanks Professor Sunil to bring their message, video message onto the stage. I must admit here that the Science Media Center is blessed to have very active faculty in charges. Dr. Harna Chakrapani and Professor Aruna Mukherjee is here with their constant support, and has been crucial for Science Media Center to make better content. I thank the BSMS students, Anup Anand Singh and Manish Tikam, who took the initiative of this project 4 years back, where KP Madhu, he's also there on the group here, I think, has been guiding them in the beginning, and Professor Bhas Papat for support for their travel to Gujarat for the coverage of that event and get these interviews. Thanks to Samir Tukral, who gave the voiceover, and Ankur Panchal for the sketches that have been. You have seen the colorful sketches. And thanks to Kirti for supporting the production. And I also thank Dr. Shanti for being, helping us with suggestions to improve our film. And Anil Sankar for sharing some of his footages for our film, especially from Cambridge, as well as the interview footages of Professor Hamik. And I thank IISER Pune for allowing us the auditorium, and Khandekirji, who sits inside there, for technical support. All the SMC members at the SMC Science Media Center for making this event happen. Last but not the least, I thank you all for your valuable time. Thank to all who have helped us directly or indirectly to make this film happen, this event happen. I missed one thing, I'm sorry. Dr. Suchiprata, who actually officially finished the documentary, they completed the film. Yeah. And Pradeep, he's also here for going all the way to Gujarat and record their interviews. If I miss anybody, I'm really sorry, and I wish you all the best. Thank you.